Okay, let's start. I remember that this is the we are recording the online class, our online class, and we solved in the previous section these MCQs until number 15, and now we are going to solve number 16 to conclude the MCQ. Okay, so the MCQ says that if f has the following Taylor expansion, right, which for x tending to 2, then we need to find the statement that is true, right? So basically, I don't need to keep this one down, let's load down. So let me see, so we have that f of x is equal to 4 minus 3 multiplied by x minus 2 to power n plus little o x minus 2 to power n plus 1. Okay, crazy stuff. Now this is the Taylor expansion of order what? Because typically is the Taylor expansion of order n plus 1, right? Because we don't know n. Yeah. So this is the Taylor expansion. So we have this is the Taylor expansion of order n plus 1, right? Nice. The first statement is that if n is odd, then f has an inflection point at x equal to. If n is odd, then f has an inflection point at x equal to. But you see, I will say this is false, because suppose, for example, that if n is 1, what will be the expansion of f of x? The f of x will be equal to 4 minus 3 multiplied by x minus 1 plus little o of x minus 2 by x minus 2 to power of little of x minus 2 square. Yes or not? No, this is 2. Okay, but this function, if you mean that f of x will be equivalent to 4 minus 3 multiplied by x minus 2, yes or not? But what is this? This is just a line, right? So this is a line. Doubts? So the function in the neighborhood of 2 behave like a line, so there is no inflection point. So for n equal 1, there is no inflection point, but they are saying that for any n which is odd, there is inflection point. But if, for example, if n was equal to 3, that at that point we will have f of x equal to 4 minus 3 into x minus 2 all cube plus little o of x minus 2 to power 4. At that point, it's clear that this function x minus 2 cube just means that you take the function x cube and you move it to 2. Yes or not? And this x minus 2, this minus 3 multiplied by x minus 2 cube will be some, and okay, you move it to 2 and you keep it, you push it up of 4 to 4. Yes or not? So if you represent it, this is 4, it will look like this. Yes or not? So by the way, so at this moment, yes, you will have inflection points. So if n is odd, okay, if n is odd and n is greater than 1, yes, we will have inflection points. Okay, because but if n is just odd, it may be 1, and if it is 1, we will just have that the function behave like a line. Yes or not? So there will not be inflection point. So A is false. If n is even, f has maximum in x equal to 0. This is false because we have the Taylor expansion at which point? At 2. Yes or not? With the Taylor expansion at 2, we can just give information at 2. But here they are asking me some information at 0. So if I have the Taylor expansion of the function at 2, I can just give information about that function at 2. It's not possible to give information at 0 having a Taylor expansion at 2. Okay, so I repeat, if I have a Taylor expansion in x0, I can just give information in x0. All the other information they ask me which are not related to x0 are false. Okay, C, the Taylor expansion of f of order n centered in x equal to 2 is this. In fact, look, this is correct. Why? Because I told you that what they gave you here, what you have here is the Taylor expansion until order n plus 1, right? When you have the Taylor, if you want the Taylor expansion of order n, you will just take all the stuff until order n, yes or not? So f of x will be equal to 4 minus 3 into x minus 2 to power n. These are all the stuff until order n, yes or not? But you write plus little o of x minus 2 to power n. This will be your Taylor expansion of order n, yes or not? This simply means that the derivative of order n plus 1 was 0, yes or not? So the Taylor expansion of order n, so C is correct because it's what it's saying. And also, if you do not understand this, imagine, for example, to have the Taylor expansion 1 plus x squared plus x, the Maclaurin expansion plus little o of x cubed. If I ask you what is the one from the Taylor expansion of order 3, the Taylor expansion of order 2 is direct because you just take the stuff until order 2, 1 plus x squared, then you add little o of x squared. Is that clear? If I want the Taylor expansion of order 1 here, it will be f of x equal to, I take the stuff until order 1, it will be 1. There is nothing else about order 1, so it will be 1 plus little o of x. Doubts? So exactly that's what happened. Nice. So C is correct. Now if n is even, f is concave in x equal to. But concave in x equal to typically means that the second derivative at 2 is smaller than z. But imagine that, so yes, imagine for example that n is 4. If n is 4, the function will be f of x equal to 4 minus 3 multiplied by x minus 2 to power 4 plus little o of x minus 2 to power 5, right? This will means that the second derivative is how much? The second derivative at 2 will be what? But there is no square. You did the Taylor expansion until order 5, and here you don't have x minus 2 to power square to power 2. It means that how much is the second derivative? Is 0. Yes or not? It means that the second derivative is 0. As we don't have x minus 2 square, the second derivative is 0. The same as x minus 3 x minus 2 cube, the third derivative is 0. Okay, so this means that I found this n, I took n equal to 4, but I got that the second derivative is 0. It's not negative, right? So the function is not necessarily concave into. Okay, and finally f has a stationary point in x equal 1. They are saying that whatever is the value of n, there will be stationary point. Is it correct? What is the stationary point? Okay, stationary point in x equal to means that the second derivative at 2 is equal to 0, right? But is it, are we sure that for whatever is the value, are we sure that the second the first derivative, excuse me, is equal to 0? So for is it true that the first derivative, whatever is the value of n you take, the first derivative will always be equal to 0? No, because if I take n equal to 1, the Taylor expansion will be f of x equal to, as we saw, 4 minus 3 into x minus 2, yes or not, plus little o of x minus 2 square. This means that the first derivative f of f prime of 2 is minus 3, yes or not? So this concludes this MCQ, and thus the answer of number 16 was C, right? So this concludes also this MCQ, and also we conclude the recording. If you have any question, you can write. There is the space for the comments for this video. Please write your comments in that in the space, and if you have any question, so that we can discuss in the next video. Thanks.